Information travels between one computer and another on the internet in a digital form. Whatever the information is, whether it's text or images or audio or video, it has to be represented digitally. That's going to be as a pattern of binary digits or bits, zeros and ones, ons and off signals that are transmitted through the fibre, through the cables that make up the internet. But we don't transmit that as one long stream of bits. We take those files, those documents, and we break them down, or our computers break them down into small packets of data. And it's best to think of those packets as the digital equivalent of a postcard, where we have certain address information there at the top, and then the rest of the information, the message, the body of the packet there at the bottom. So looking inside one of these packets, an IP datagram as it's called, you'll see in the header section always the same sort of information being shown. One of the first bits of information in any IP datagram is the length of the datagram, so the computer receiving it knows when that message is finished, knows how long that packet of data is going to be. Another bit of information that we transmit right at the start is the ID number of the whole collection of packets, so that they can be reassembled together at the far end to make our Word document or our audio file or our photograph or our video. We also include an offset part of the header which says where in the collection of packets this particular packet, this particular datagram comes. So is it the first, is it the second, is it the third, is it the 199th? And that again is important information for the receiving computer to be able to reassemble the original message from all of those packets. We transmit a number of other bits of information too. So there's a time to live figure which specifies how many seconds that packet can be live on the internet. And that's quite useful to include that information, because otherwise packets could keep going round and round on the internet and never ever die. But by specifying that number, each packet has a natural life. If the packet never arrives, then a message can come back saying send that one again. We'll also include some checksum information which says whether or not an error, or helps the computer identify whether or not an error has happened within the data included in the packet. The most important bits of the header information, though, are the source and destination IP address. Every computer connected to the internet has a unique address number, and each IP datagram includes the address of the source computer and the address, obviously, of the destination computer. So every single packet of data being transmitted across the internet says where it has come from and where it's going to. This, of course, contributes to the digital footprint that any time you use the internet you generate. So all of the packets that your computer sends or receives identify where on the internet that computer is. The bulk of the datagram, though, this is a tiny, tiny bit of information right at the top of my digital postcode, but the bulk of the datagram is going to be the data of your message. And again, that's going to be encoded in digital format as a collection of binary 1 and 0 digits. It's worth remembering that all of the computers, all of the routers, all of the gateway machines that this packet travels through have access to the content of this packet. The internet is not a secure mode of communication. If you want to use it for something which you do want to keep secret, then it's necessary to encrypt the data here. The internet itself won't do that for you. The other thing worth mentioning is that these packets don't all have to travel the same route. Once the message is broken down into a sequence of packets there, then each can travel by its own independent route between source and destination. And as long as they get reassembled at the far end, the user of the file computer will be none the wiser as to the route that each packet has taken. How are you going to teach this to a group of children in primary school? One way is to model this, is to do this with paper or with real postcards and create your own datagrams, perhaps using a simplified version of this sort of structure here, specifying the source address, specifying the destination address and having children act out the part of routers and gateways and delivering pieces of paper to one another in the class as a way of showing how messages can be passed through lots of computers from source to destination. Another approach is to use some of the diagnostic tools that are available for desktop and laptop computers, which allow you to inspect the contents of the packet and to show children what the inside of a packet of data looks like, and to show them the ones and zeros, or at least the digital representation of the data that's travelling to and fro.